Is Rudy, one of our longtime members, had asked in my last class that I gave, Brandon gave the last two, but that if I could go over this GE dryer. He was having some problems with the GE dryer and really couldn't understand the diagram. And I could see how this diagram could be a little confusing. Just wires everywhere. And if you don't practice this every day, um, it's going to get hard. It won't get easy. I have a former student employee who has his own business now in Mariana, Florida, which is like in the panhandle. And he's been doing this thing now, I would say, about 7 years. And every once in a while, I get a phone call from a simple Whirlpool dryer that's not running. And I'm like, yo, dude, you've been doing this long, you still can't read the diagram. And some of my students take these diagrams home and I'm going to study this diagram. And they take it home and they come back the next day and said, I took it home and I don't know what to study. I'm looking at it and I don't know what to look at. So one of the things is if you get diagrams to practice, even on the internet, download them. Just Google search diagrams and practice tracing or highlighting circuits. Let's just start off here and then I'll get into what I have set up for today. Like if I wanted to go and the dryer's not working, the motor's not running. That's my motor there that I highlighted, okay? I have to get power to that motor, and one of the things I need to do is to look at the wiring diagram and see how does power flow through this circuit to feed this motor. Now, I know that it's neutral and line 1 for the motor, but if you're not familiar with how much voltage specific components are to get, or whether you start at L1 and you're like, man, I don't know how to get into the motor or get out. Start at the motor and work your way back, just following the line, back to the power source. Through here, and so forth. Oops. That is the circuit. So what I did today is I got all the parts in general for this machine. I got the heater, I got the motor, I got the timer, I got thermostats and everything, and I'm going to show you, if I'm looking at the diagram, how do I look at the timer? How do I use the two of them together for troubleshooting, and how does that help? So let's just look at this second section here. Timer sequence charts. I have one video that seems to do pretty well as far as people wanting to see it, is understanding the timer sequence chart in the dryer. Now this came off of the diagram. You guys did get the email where I sent the link to the diagram if you wanted to download it. I sent it out this morning. So this is the timer sequence chart. Let me break down a few things, and then I got a next picture which has the timer and show you how that works. So first of all, we have cycles. These are our cycles here. 1, 2, 3. Now they're both on the same diagram. Why do we have two separate timer charts but for the same dryer? We don't have two different timers. We only have one timer. What's different between the top and the bottom just by looking at the whole chart? Guys got any ideas there? The hint is in the title underneath.
On the top one has some different options.
Well, the top one has extra care, which is part of the time dry cycle. Well, auto dry, I mean, but I'll get into that as we go through. But we also have extra care also on the permanent press and the cotton. We don't have them on these two. And if you look here, does anybody know what this information means? 360, 225 min.
Is that when the thermostat opens and closes the heater?
No, it has nothing to do with it. This is all timer. And, well, first of all, the 360 is 360 degrees. So the timer, you can turn the timer all the way around, right? 360 degrees. But that 360 degrees is a total of 225 minutes of time cycle. Now, if you look at this one only has 180 minutes, which is about, what, 45 minutes difference. And that may be because of these extra care cycles that are added onto it. Nothing big, just pointing things out that you're looking at and what you need to look at. So it also has a signal, which would be like your buzzer at the end of the cycle, where the other one, the dryer down here, has less options. It doesn't have extra care, and it does not have the signal timer switch for the buzzer at the end of the dryer. So now these here, A and B, I think that's a K. We'll take a look at it in a minute. BC, TX, and TF. Those are all switches on the timer. Those letters are where the wires would connect to the timer. And those, I'll point them out to you in the next slide where we actually look at the timer. Let's look over here real quick. This information on the diagram here and here, and they even put it here, not many people even put the word, is called a legend. If it has a T, that means it's on the timer, and if it has an M, it's on the motor. So if we looked at the wiring diagram here, this one right here says TS. So the T in the front means that's in the timer. Now only GE does this, it's not for every manufacturer, but the T's in front of it, TX, TS, and if we go TA, BC, the first letter just means it's on the timer and it's pin A or it's pin B, and that's where the wires connect. Now if it's in the motor, you can see here M5, M6, we have M4 over here, so this whole thing is the motor. And then we have M1 and M2. Now I do a lot of lectures on dryer diagrams. What's missing if you're looking at all those there? We have M2, M1, 4, 5, and 6. What do you guys think is missing from this diagram?
How about M3?
M3 is correct. Do you know where M3 would be located? Right here. So it's on the motor, and it's on, those are the wires that are on the actual centrifugal switch of the motor, and I will point them out to you. But I do not know why manufacturers on all diagrams, they don't put M3. It may be because all the ones with the M's that are showing in this diagram now have wires that are connecting to the motor from someplace else in the machine. M3 does not have a wire coming from the timer or from the door switch or anything that goes to M3. The only wire in M3 is the motor winding inside the motor, but that's what's connected there. So those are just the numbers and so forth. Now if we look at the timer chart, let's just say AB as the heater. So AB is right here. Here's B, TB, and TA. It's this switch right here. And if we followed it down, we can see that goes to our heating element. So that's how we look at the timer switches inside of that diagram. That switch controls the heat. Now, if you can go to there, look at the chart and tell me, let's use the bottom one now, because the bottom one's more like the one we have on the diagram. Which one is going to our motor?
Like B to C.
B to C, right? So let's go back to that diagram. And if we look here, here's B to A, B to C is here. So that power's coming into the timer on B, and there's two separate switches that go out, and this one feeds the motor. So that's what that means on the chart. Let's go one more time to the chart. Now we got to look at this main body or information here. And that's what's on the right hand side here. If it has horizontal lines, it means it's intermittent. I'll explain that in a second. If it's a solid or darkened lines, that means that the switch is closed at that time. If there's no line or nothing, it means it's open, and then X means it's only closed for a minute, or not a minute, but a moment. It could be just 2 seconds, 3 seconds. But anyways, if we started a cycle, let's look at this timer chart here. Not the timer chart, but the actual control panel. I'm going to zoom in on the timer portion of it real quick so y'all can see it, because I know some of you may be looking on smaller devices. If we look here, how many cycles are on this timer dial?
It's like 3.
There's 3 cycles. We got Cottons here. We got Easy Care and Time Dry. So if we go down here, and I'm going to use the one on the left, it's a little bit more simplified. And let's just say I put my dial, okay? I'm going to put the dial, let me put it, the arrow's pointing right about here when I turn the dial. Where am I on this chart? Where am I?
Well, it's ending up in C. I would think if you're going 360, A, B, C is left, I mean, right to left. So I would say you're B to C.
Okay, well, let's take a break for a second. Then B and C, if you're referring to this, is only one switch in the motor or in the timer. But when I'm asking where is my pointing here, I'm asking where are we in this chart? Like if I was to pick a point, what am I pointing to? So here, let me give you a little more information. We have 3 off positions. 1, 2, 3. We have 3 off positions.
All right.
The name of the cycle is Easy Care, but I'm gonna have to erase this just for a second. What we need to do is actually read a little bit further to what it's saying here and here. So again, if I'm right about here, which one of these 3 cycles do you think I am in?
I think you're going to be in the normal time cycle, because that's going to be time that's running. So you're close to the middle of the cycle.
Actually, no. If you look, if you look here, Easy Care is permanent press because it's hard for you to read, but right there it says perm press. So this off position right here is this off position right here. Now, as the timer rotates to the next off position, that is the timer moving across this line to this off position.
Okay.
But now I go through time dry to the next off position because I'm not to my arrow yet.
So you're in an auto cotton cycle at that point.
Exactly. And where in that cycle would I be is probably about here, right? If you were to say the off position's here, here's the off position. The other off is here, which would be the end.
Yep.
And I'm about a third of the way into the cycle. Now, one of the questions they might ask, well, how do I know exactly where I'm at? You don't. You'll never know exactly where you're at inside of this chart here. You only get a close look or area of where you're at. But what we want to do then is if we go downward here, any one of these that have the dark hashes means right now inside the timer, that switch is closed. So how many switches are closed right now?
3.
3, and they would be A to B, which is this one here. We followed over to the left, so A and B is closed, B and C is closed, and T and F is closed. You see
So
that?
the meter's running, the motor's running, the timer's running.
Exactly. So this is how we use the chart when we get into a specific cycle and something's not working. You're like, well, damn, that timer's got 30 switches. How do I know which one's closed? Well, washers and dryers that have mechanical timers like this are going to have a chart. You just sort of got to figure out, okay, well, how many cycles do I have? Because this diagram actually gave you 2. But this one didn't have that additional extra care built into it, so that's why I'm using the one on the left. Once I figured that out, now I have to figure out what cycle is this. Well, this is the cotton cycle, and I'm about a third of the way in. I still have 2/3 of the way the cycle to go. And then I come here and I find what switches are closed. So here's the timer. And let's just go with the same cycle we are. We said A to B is closed, B to C was closed, and down here in the bottom, T to F is closed. So A to B, if you look, is right here and right here. So there's a switch inside this timer, just like this, got a little point on it, and you got another one over here. My drawing's terrible, guys. I don't have my active board, so it's not the same. But A would be here, and B would be here, and when the timer closed, those two would make contact. But we also got what? B to C, right? Well, B is also touching another one. So all three of them would be touching at the same time. When I want to check and I don't have any heat, I'm really not going to look at B to C or T to F, and I'll show you on the diagram where they are again. I'm looking for the one for heater, and I'm just going to check A to B. So if I was to tell someone over the phone, hey, switch A to B might be bad, I need you to check it in the timer, what other information do I need to tell somebody in order for them to test that switch?
That we're looking for 120 volts between A and B?
Actually, what I would like you to do is a continuity test or ohms test on the switch. And reason being is a switch is on line 1 and neutral side, or is it line 1 and line 1? In other words, if I had a light bulb here, this switch would turn the light on and off, right? But where's my neutral? My neutral is here, and my line 1 is here. When the switch is open, neutral backfeeds all the way up to here, and if the switch was open, I'd have 120 volts. Does that make sense? Got any questions there? No? Okay, so but when the switch closes, like this, line 1 comes all the way to the light bulb. So if I put a voltmeter across a closed switch, it'd be like going into an outlet. You got neutral and line 1, and you put both meter leads in the same hole. What's your meter going to read? 0. So on a closed switch, if I did a voltage test, what would my voltage reading be? I just said it.
0.
0. Okay, so with that logic, if I check the switch and I had 120, that tells me the switch is open. If I check the switch and I have 0 volts, that means the switch is closed. But that's not a good test. Can anybody tell me why it's not a good test? Because watch this. What if I'm checking the switch because the light bulb's not working, right? What if the light bulb's broken? On an open switch, what's my reading? 0 volts. Why? Because I can't get back to neutral. If I get a closed switch, what's my reading? 0 volts, because I can't get to neutral. And then if you did that, you would say that that switch is bad, because you got 0 volts on both sides. Something's wrong with that switch, because it's supposed to give me voltage when it's open and no voltage when it's closed, when the problem is my light bulb. So whenever you do voltage, I want you guys to use the actual load, the light bulb, the motor, whatever. And if you don't have voltage there, only move 1 meter lead back to find where the voltage is. How far did it go? But going back to what I was saying is, I want to check this switch for ohms or continuity. Unplug the machine, disconnect at least one wire, and test it. But the other information I was really looking for was, like, if I'm telling someone to check that switch on the timer, you have to be in the cycle. You have to have this dial pointing where that machine's not working. If it's automatic or timed or whatever, I have to have it in that cycle when I'm checking that switch. I can't have it in the off position, because in the off position, heck, the switch isn't even closed. So you have to have it in the cycle, and that's the important thing to do so you don't get it wrong. So let's take a look at the normal time cycle we have on this dryer. Let's go to here. Now these numbers here are actual times. So if I put it right here, I put it on the 80-minute mark, the timer will advance this way until it shuts off. That means it'll run for 80 minutes before the cycle's finished. That's what that is. Time cycle has a specific time that it will run. Automatic cycles, they depend on the operation of the thermostat cycling on and off for time. So they're never the same time ever. Like, lady could put it on this one spot on the timer, and it took 30 minutes to dry, and tomorrow she uses the same cycle but has towels instead of t-shirts. Well, it's going to take longer to shut off. It's going to extend how long it takes to run. That's what auto cycles are. They're the same heat, they're the same motor turning, the same fan moving air. They're just controlling the timer, how long it takes to shut the machine off. So basically we do the same thing, but we sell the customer 3 different cycles for the same thing. Make more money. So let's go back to this chart now. The switches that are closed on this timer are A to B, A to C, and T to X. That's right here, it's shaded here, and T to F is not closed right now. So let's go to the diagram. A to B is closed, so right here is A to B. B to C is closed right here, and T to X, which is over here, is closed. So look, this is timer switches, and timer switches drawn here, but they're really all inside that same part, because T and F would have been probably this one here, or T and X. This one T and F is this one here, which they don't have on some of the timers that I looked up. Some of them have it and some of them don't. That's really weird. But anyways, going back to A, B, B, C, and T, X, once you highlight them, this is how the circuit is. This comes in, goes through here, waits for the customer to press start, passes current through, and goes out. And that's the motor. All right. So what happens in the circuit once the motor starts up? All I'm doing is I'm pressing the start button and the motor starts running. But what happens to this start winding when I let go? Or I'm sorry, not start winding, the start switch when I let go.
So as I understand, the start switch, when you let go, it moves to run. So it moves from start to run.
Not on this one. The start switch, I don't know if you mean the centrifugal switch, but I'm talking the push to start switch. Now the push to start switch, you see it's like a letter T upside down. That's a symbol for something called a momentary contact. In other words, it only gives you a reading while you're pressing down and holding it. If you let go, it opens back up. Now, if you look at the diagram, I press it down, the motor runs. If I let go, what's going to happen to the power to my motor?
Yeah, I think I was thinking start versus run winding. Okay, I got you.
Yes, but when I press it and I let go of the start button, what happens to the power to my motor, though? Anybody can answer it.
It's still, the motor still runs because the start winding comes out, but at the same time there's a switch between, I think it's M5 and M6. That closes.
Very good. So when you press this button, and this happens, You know, like you just press and let go and the dryer stays running. This switch in the motor here, which is called a centrifugal switch, closes here, disconnecting the circuit for the start. So the start is not getting power anymore. We can damage the motor if we keep sending power to it. But the power goes around here to the motor. Now, I had a technician call me. Oh, you know what? It turned out to be the same guy I talked about at the beginning that worked for me and didn't know diagrams that well. He says, Richard, man, he says, I press start and the dryer's running. But when I let go, it stops running, doesn't run anymore. So look at this circuit and tell me what things you would check for that problem.
The centrifugal switch.
From where to where on the centrifugal switch?
M5 to M6.
Okay, so M5 to M6. I'm sorry. Is there anything else? There's one other item in that circuit there that could possibly cause the same problem.
Idler switch.
Idler switch. What is an idler switch, if someone doesn't know?
It is a switch that's connected to the idler pulley.
Yeah.
If the belt gets broken, it switch opens and doesn't provide power to the motor.
So it could either be a bad switch or the customer could have a broken belt, right? So you could easily see if the belt's broken by holding the door switch with the door open and pressing start and seeing if the drum's turning while you're holding the start button down. But the belt switch is very common on this manufacturer to cause this problem, and a lot of people think it's the timer, they think it's the motor or something else. But I'm going to skip something here. I got a lot of stuff to cover on this. This is probably going to have to be a two-part class. So the next class I'll do whatever we don't cover here. So here's a centrifugal switch. I got pictures on both sides. We said 5 to 6, but I'm going to zoom in on this switch. Now this is the same switch, it just flipped over so you can see both sides of it. But let's take a look at it because I want you guys to see something. There's numbers on that switch. Can you guys see those numbers?
Yep.
It's a little hard to see, but like we have right here 6, 7, I think that's 8, 9, 5, 4, blah 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 blah, and so forth. 1, 2, 3, 4, whatever. Guess what? Don't worry about those numbers. Those numbers don't mean anything, and I'm going to explain to you why in a minute. Those are not the numbers that are on our wiring diagram. These are the numbers on our wiring diagram. 3, well that's 6, 4, 5, 1, 2, and guess what? They didn't even put the number 3 on here. They don't put the 3 on the diagram and put the 3 on there, but those numbers we're looking at are these numbers here. So if you look at it, this screw is a ground pin which is located right here on our motor. It's a little hard to see, but it's located right there. And these numbers right here are just above the edge of the motor on the front. These numbers are on the back side. Do not confuse them, and don't look at the numbers on the back. You have to look at the very edge here to see the numbers. Now if you notice, look at these two pins, how much bigger they are than these little ones over here, because these two are pins 1 and 2 for your heater, these two right here. And the reason why they're bigger pins is because the heater draws more electrical current. And these 3 are your motor 4, 5, and 3. This is pin 6 right here. Okay, that's this one right there. 3's like right there, you just don't see it. And you can see these 3 together right here. And if you look at these wires, you have like a light blue, purple, and orange, those are the motor windings, and those are the small 3 pins that you see here. So going back to the diagram, this 5 and 6, you'd have to look at this switch here, and you're going to check 5 and 6 here, which would be this one, and I think it's this one right here. Those two right there. Okay, this is actually 3, 4, and 5 right here. Those numbers are the numbers we're looking at here. Okay, there's one more thing you need to do to check 5 and 6. What do you need to do to check 5 and 6? You know, we unplug it, we got down to the motor, we found 5 and 6, we put our meter on it, and our meter right now says the switch is open. Is that good or bad?
You have to push it on the centrifugal switch?
Yes. So if you're not familiar with a motor and how the centrifugal switch works, these little beige little pieces hanging off the bottom are down around the shaft of the motor. I don't know if I can get let me see if I can just see a picture of it while I'm talking. 1 second. And there's a little black collar that's inside of the motor. This one doesn't show it. Let me see if I'm trying to find something that actually shows the collar that you press down on. This one might be visible. Let me see if this motor here is visible. 1 second. I'm just opening up a slide here. So inside the motor, a lot of times you can just get your finger in there and you can move this piece. Again, remember, we're talking about power. If you can see, zoom in underneath that metal piece, like right here, that I don't know if I can, okay, here we go. There's a little black collar right there, and it goes all the way around the shaft of the motor, and you push it down, and that's how you activate the centrifugal switch. By pushing that collar inside the motor, you get your finger in here and push on it, you're moving these two levers and you're causing the switch inside here to either open or close. So in order to check 5 and 6, according to the diagram, the only time this would be closed is when the motor is running. And in this case here, when you're testing the motor, there's no power, so you have to move this, which makes it think the motor's running. Does that make sense? So you're going to put your meter lead on 5 and 6 here, which will be 5 here and 6 here, or vice versa, 5 and 6. I don't remember which one it was the way laid out. But then you reach down and you press the lever. When you press it, it should close, and when you let go, it opens. Now, before I do that, I would check the belt switch, because the belt switch is located right there next to the motor, and it's easier to test because a lot of times on these GE, you can't get right to the wires right away. You have to stick your head down inside the dryer and everything to find the wires. So to check that switch here, we want to do that. So we want to check these two things if the dryer only runs when the start switch is pressed down. Now, could someone think the start switch is bad if you pressed it down and the motor didn't continue to run? Could it possibly be a start switch? I'm trying to find, I have you guys on one of my screens and I can't can't figure out which window I have open for you. There we go.
Well, if you have continuity on the switch when you test it, would it show that it's functioning at that point?
It's functioning when you're pressing it down, but the problem is you need to know what type of switch that is. And Whirlpool doesn't always use one of these momentary contact switches. Let me see if I got this diagram right here, and I can show you that if you look at Whirlpool, sometimes they use the momentary contact, but in this case they're using, what did I just do with that? I just had it open. Here we go. Look what they have for us. Do they have the same T-shaped start switch that we had in the dryer, the GE dryer?
Push to start.
This is a push to start relay.
Wow.
So that power has to go through here to feed the motor. But if that switch opens, does the motor get power anymore? No. But when you close it and send power to the motor, power also goes through this coil right here and goes to neutral. That's a magnet that holds this switch closed. So now instead of a momentary switch like our GE, and I'll put them side by side so you can compare them. Let me just move it over here. That if you look, here's a push to start relay. It has 3 terminals on it with a magnetic coil. This only has 2 terminals on it. Okay? And when you let go, there's another wire here that bypasses it. We don't have any other way to send power to the motor except through that switch. So if this one failed to keep the motor running after you let go, it could be a defective switch. The coil could be bad, the switch could be, not the actual contact, because if the motor ran at all, the contact's good, it's just the coil's not maintaining it closed. So that is the motor circuit. I want to go here. We have our push to start switch and our temperature selector switch here. The selector switch and start switch. Now I just got finished telling you that push to start switch only has 2 terminals, and look what I found. I went on the internet, I took the model number that the one guy that asked me to do this class today. I looked it up, and the diagram came up with a 3-terminal switch. But we're not using a 3-terminal switch on this machine. We're only using a 2-terminal switch. Yes, we have 2 wires on one side and 2 on the other. Does anybody know what that 3rd terminal would be for if the machine was using it?
Could it be ground?
Not ground. It would be the buzzer. In other words, you would push it to start, but you would turn it left or right to turn the buzzer on or off. So pushing it started the dryer, but turning it disabled the buzzer at the end of the cycle. So let's take a look at this information, and I got more parts and more of the diagram I want to go over. So here's the selector switch. Again, just like the timer and the dryer, if the customer chose cotton, what switches or contacts were closed? If you're in a selector switch, let me see if I have it here. Now let me bring the switch on this side here. So here's a selector switch, and I'll zoom in so you guys can see the numbers of it better. We have 8 here, 15, 16, 7, and I think this is 6. Okay, because we got 6, 8, 7, 8, 15, 16. But I chose cottons. That was my cycle that I chose. What contacts are closed in that cycle?
15, 16?
15, 16. What about 6 and 8 and 7 and 8?
They're not being used.
They're not being used in that cycle. What about delicates?
Everything.
All of them are closed, right? 6 to 8. So let me move this switch down a little bit. Let me get it so we can see the whole switch on the screen at the same time. So let's just say delicate 6 to 8. So that's from here, 6 to 8. Let me redo that. That's a horrible drawing. 6 to 8 right here. There's a switch between those 2 pins, 6 and 8. I know you can't really see 6, but 6 is, I think, right there. Okay. What about 7 to 8? So also there's another switch in here, and 15 and 16. So if I was to test this switch, I'd go to this chart. Depending on where the dial is set, just like we talked about the timer, where the timer dial was set at in a cycle, where this is set in the cycle, you see here which one's highlighted or shaded in, telling you if I chose this setting, these are the switches that are closed, And this is how I would check it. I check 6 and 8. I put a meter lead on 8 and a meter lead on 6 and see if that switch is good. But again, the dial has to be in that setting. Now if you see our start switch, it only has 1 to 2. I'm not going to go over that too much. Do you guys have any questions about this chart and how this works? No? Okay. Now the other information here is they're giving you temperatures on the outlet of the drum. That's right where it goes into the blower fan. Okay, we got a thermostat that runs at about 135 degrees plus or minus 5. It opens at that temperature and then will close back at 125, keeping an average of 130 degrees. The biased control inlet, and I'll talk about that in a minute, runs at about 210 degrees. Okay, the thermal high limit is 315 and the safety is 210. The bottom two are usually not resettable. Those are usually high limits or safeties that if they go bad, they just open up and they don't work anymore. So let's take a look at this circuit for the motor. Let's go here. Power comes in and goes where? Where does it go to? What am I going to? I stopped the line there. Where am I going? Anybody?
The control timer?
Go where on the timer? To B, right? TB?
Hmm?
So if I take this timer and I'm going to make it real small and put it right here, power is going to go to B on the timer. And then was it A or was it C that it went to the motor?
C.
TB and TC. I'm sorry. Yeah, TB. And then it goes C. Now what am I going to next?
You go through the high
The higher limit?
The thermal, right? The high limit. So then this little piece is going to be here as the high limit. Got 2 wires on it. And we're going in and back out. Now what?
The push to start?
Push to start, and I'll just rotate it around so the 2 terminals are on the top. And that would be here. So power goes to that switch. And from here we go to what? The motor. And again, it's going to the centrifugal switch of the motor. So we got a wire here. Jumps from here to pin 5 on the motor. And it comes out pin 4. The overload protector is not a separate part. It is internal to the motor. It is drawn in the diagram to let you know that it's there, but it's not a part you could replace separate. It is part of the centrifugal switch at motor assembly. If we look at this motor here, this little piece right here with the orange and red wire on it is the overload that you are seeing in the wiring diagram. So that overload is right there. Pin 4 is on the motor, so actually the motor would stretch this far. And then we go to what? The door switch. Now I'm sure a lot of you are capable of just ohming out specific components. Just trying to read the diagram and the entire circuit is where you're having your biggest issues. But if you look here, that diagram, that's what's going on inside the machine. Power is coming from the plug. It goes to terminal B on the timer. From there it comes out C to this thermostat. From this thermostat it goes to the start switch. From the start switch to the motor back to the door switch, and the door switch out. Now if you are troubleshooting this dryer and this motor didn't even start at all, you made sure you had power coming in. Well then you're like, okay, I got power, this motor ain't running. What do I test? I remember when I first started working on appliances, I was really good at diagrams, really good. But I would look at circuits and sometimes go up to a machine and see something not working, and I'm like, I don't know what to do next. I don't know where to begin my testing. Well, what you do is you look at this circuit like we did here. And we highlighted the power and how it goes through all the parts. The next thing you want to do is you want to identify the parts that send power to your motor, besides the motor itself. If any one of those parts are bad, the motor don't work. So you have to use the diagram to identify the parts, and then you have to use the meter to test those parts. So what is important besides this diagram? What do you guys think is one of the most important things you guys need to know when you're doing these tests?
Where to put your meter on the parts.
Where to put
the diagram.
Where to put your meter on the parts, which is very good. But to be honest with you, you know, I teach a school where the guy comes in to me and says, I don't know what the difference is between a dryer and a washer. And, you know, I tell my students, when you work in every machine, if I walk up to it and point to a part and says, what's that part? You better know what that part is. So if you do have spare time or free time when you got a machine, is not only read the diagram, but you need to know all the parts. You need to know if I gave you a part, it says, oh, that's a selector switch, that's a start switch, that's a cutoff, that's an operating thermostat. Now I know how to test an operating thermostat. I know how to test an operating thermostat. If you gave me those parts and a bunch of wires, I could go to a table, connect every single one of them, make that dryer run on the table. And I can connect them in the order that I see it on here. Those are the things you guys need to practice when you are working on machines, is to find parts. And if you don't know what a part is, you know, sometimes when you go to a machine and you look at a part that's got wires on it, you're like, well, I don't even know what that part is. So if I don't know what it's called, how do I look up information to find out what it is and how to check it? Well, look at the color wires. Like if I was looking at a signal and I didn't know what the signal looked like, well, it's a red and a black wire going to it. How many parts here have a red and a black wire going to them? Here, let me just clear all these lines. I have one red wire here. I have a red wire here. I know that's a timer, but I don't have any other red wires, so I guess if it's got a red and black wire in it, it must be that part. And you see this switch right here? This switch would be that third terminal on that start switch that I showed you here. That third terminal right here is going to the buzzer. So let's take a look at the heating circuit. You guys want to tell me what part goes first and what two terminals of that part I'm going to use? Starting at line 1, power comes into the heater. Where does it go?
To the timer?
Timer where?
Like
The
TV.
TB. So I'm going to put the timer here. B is the one in the middle. So I'm going to connect it to the timer. It's going to go into the timer. Then from there it comes to what? How does it come out the timer? It went in. Now we got to come out.
The TA?
TA. So I'm going to come out A and I'm going to go to what?
The selection switch?
Is it here? Nope. We don't have a selector switch. Well, dryer won't work. Let's steal this one. I'll give it back when I'm done with it. So here's the selector switch. Now we need to go to the diagram because I don't know what switches in here are closed right now. So let's go to the diagram chart here. Pick a temperature. Go ahead.
Cotton.
Cotton? Okay, we're going to do cotton. So how many switches are closed right now?
15, 16.
Just 15, 16, right? So let's go back over here. And we got 16 here and 15 there, right? So let me undo that. Let me put that switch on the diagram. And I'm going to rotate it so it lines up with the way the diagram is. And 15 and 16 are these two here. I think I have it backwards, but we're going in here and we're going out here and we're going out this wire. Those other ones are these other pins we're not using right now. So where do we go from here?
Safety thermostat.
Safety thermostat, which is this one right here. We're gonna go in and out of that, and it's gonna. Next we're gonna go to what?
The outlet thermostat.
Okay, we're gonna go to this one here, but there's 4 pins on this thermostat. Which two? There's one here, and one here, and one here. There's a total of 4.
The orange and white.
Not the colors. Which pins on the actual thermostat? The 2 small ones or the 2 large ones?
2 large ones.
So the small ones are where? Where are they on the diagram? These 2 pins. Right here, guys. This little thing that looks like a heater.
Yeah.
That's what it is. There's a heater here, and if you were to ohm it out, I think that says 9 kilo ohms or 3 kilo ohms, but that's what it is. But from the 2 bigger ones, that's an actual switch where the switch looks like this. It's got a little prong on it, and then there's another one here. That's these 2, and that's what this is, a switch here. So if I connect this one like this, I'm gonna put it like this, and I'm gonna go from here to here, and we're gonna go out here. Now where do I go? We got 2 directions to go. Which way does it go?
Well, it goes in both, right?
It goes in both on this one, yes sir. So we're going to go to white to the heater, and we're going to go through the next thermostat, which is this one here. I just put 2 of the same one because I got tired of trying to find the exact one that came with the part. And again, we're going through the switch part, not the heater part. I'll explain to you what that is if I get time to do that today. So it goes through the switch here and here. So what's different between these 2? And why am I going through a separate thermostat on one and then the other?
There's 2 coils on the heater.
Okay, we got 2 coils, and so the upper coil is going to be controlled by this thermostat. The lower control is going to be this one. Most likely this thermostat temperature is lower than that one, because if this one shuts off, they both shut off. If this one shuts off, it only shuts off the outer coil. So if we were to look at this, I'm going to zoom in real quick, get the motor out of the way. And so you got 1 terminal here, and you got another one here for the inner coil and the outer coil, and they all come back here to a single terminal here, which is this one right here. So this one is the pin on the right side of the heaters, and these 2 pins here are the 2 coming in. So if you guys got questions, don't hesitate to ask. But that's going in. Where do we go from there?
The purple wire of doom.
The purple wire to what?
That's funny.
The wire of doom, the one that keeps melting.
Oh, really? I have never seen any of them melt, but...
A lot of them.
I've seen like 10 of them.
Yes, sir.
Okay, so why do you think it melted?
Maybe the control thermostat is bad.
No, it really don't have anything to do with the thermostat. If you got a wire that's burnt, there's only 2 things that'll cause it. One is if the terminal connected to the heater was loose. Have you ever like plugged a wire on and you let go and it just slipped right off because the terminal wasn't tight? If it's
Yeah.
slightly loose, it actually causes a higher amperage at that point, causes it to run hot. Now the wire's running hot from inside, the wire's melting the plastic, which eventually burns. The only other thing that would cause that is if the element terminal itself, where the wire connects, is like rusted or corroded. That would also cause a higher current draw and cause a premature failure. So if you ever ran across that, always sand and clean the terminals on the element if you're not changing the element, and make sure when you plug the wire on, it should be almost as tight as if, well, the only way I'm going to get that wire on is if I have to shove it on with a plier. I mean, don't make it that tight, but that's what you're looking for. You do not want it to have any play or be loose, or it's going to burn up again. So you're going to fix it and it's going to come right back, especially if you fixed a burnt one. Okay? So where do we go from here on the heater?
Hey, Rich, I got a question.
Yes, sir.
In terms of that last comment, and basically everybody's observation that these, like it's a common failure.
Mm-hmm.
Why would that, I mean, obviously, it's probably going to be tight coming out of the factory. You know,
No. That's,
no, it's not. I mean, I haven't had one, so, but I know it's a problem.
It is. It could also be the fact that maybe they whatchamacallit, my mind's going blank here real quick. Give me 1 second. I'm doing something on the computer while I'm doing it. So they might have used the wrong wire size in manufacturing. Maybe it was a number 12 wire they used instead of a number 10 wire. And so it always runs hot. And is that the wire you're talking about?
oh yeah.
That's the purple wire, ain't it?
Wire doom.
I found it. So, and you could see where it burnt off. Where did it burn?
Right at the spade.
Why were they crimped it? So what do you think happened? Maybe the terminal itself is inferior, or their crimp was not good. Whoever's fabricating the wiring harness in the factory is probably making mistakes. Or that terminal here, they tried to save a few cents and went to China or Mexico and bought these terminals from them, and they're lesser quality and they can't handle the amperage. Why do you think the purple one's burning but not the blue or the white one on the other side of the element? Because the white and the blue are only controlling the inner or the outer element, so therefore that wire is not carrying the full amperage of both elements. But on the other side, that purple wire is carrying the current of both elements on the output, not the input, so it's handling more current than the blue or white is by themselves. You could take the current from the blue and white and add them together, and that's how much current's on that purple wire. So that could be why it's burning, and having good quality wire terminals will make a difference, but you can see discoloration here. So I would always take a little emery cloth or sandpaper or something and scratch that sucker till it's nice and shiny, so that way when I leave, the new terminal don't burn back up. Did I answer your questions?
You
Yeah.
did.
Okay, so let's I'm sorry, my screen just went to sleep for a second there. So let's finish this circuit out, and then I'm going to create like a little assignment if you guys would like. I'll put down some questions. This is happening, that's happening. We have voltage here. What parts would you test? Why would you test them? How would you test them? What reading you get? Like a little test for you guys, just as a quiz for you to look at the diagram and see if you can answer them. In next class, I'll make that part of my class, explaining it, and I'll try to make it a little more interactive if I can get parts from a machine and actually demonstrate them for you. Can't guarantee it, because on Saturdays we do it from home, but maybe I'll go to TMM and do it from there. Oh wait, you know what, guys? Then I apologize, but we're gonna send out a memo The next class, which is scheduled for the 15th, we're either going to put it on the 8th or the 22nd, because Brandon and I have a hands-on sealed system class coming on that week, and we'll be training both of us that weekend. So I'll put out an email this week and let you know, but I'll create some assignments and stuff for you guys to practice and ask you some questions about this. Later tonight, I'll put this video up in the members section. I'm redoing the members videos and redoing the website a little bit when I get a chance. And I'm going to start putting the like a list of what videos are in what section. And whenever I add a video, I'm going to put the date that video is added. So if you ever go and you're like, man, did they put up any more videos? Usually I email when videos go up, but I will let you guys know. That way, if not, you can always go look and say, oh, this was uploaded in January 2025. I haven't seen that one yet. And you know what videos have been recently uploaded by the list. But let's finish this circuit. We're coming out of the motor on that dreaded purple wire. So where does this purple wire go in the machine? Where does it go from here?
To L2.
Oh, you're missing something though. Because if you look at L2, it says it's black.
Oh, centrifugal switch.
Yeah, say it real fast. Centrifugal. I have a lot of students that have a difficult time saying this, so don't worry about it. So centrifugal switch would be these two large terminals right here. If you look at it, this one and this one. So that power would go from here into the motor and here out, and that's the circuit. So if you see, that's the parts and how they are connected internally into the machine. So next week or the next class, which may be next week, I'll put a memo out. I'm going to put some questions out early in the week and put a notice of this class. And I'm also going to go over how these bias thermostats work in this circuit. Like what do they do? And also the timer in time dry and auto dry, go on how they work within the circuit. I didn't have time to get that today, but if you guys have any other questions, this is your opportunity to ask, and I'll be more than happy to help you out.
Would you happen to have in your archive a video on how to replace a GE side-by-side heat exchanger?
A GE side-by-side heat exchanger. No, I don't think I did. The only heat exchanger I have was the top mount one. On side-by-sides, the only difference is you cannot cut the capillary tube short, but you can cut the suction line. So if you purchase a heat exchanger, give me 1 second, I can give you a little bit of advice. If you watch my video on changing the evaporator and heat exchanger, that's the same process. The only thing different is the length of the line. Hold on a second. I'm going to do a Frigidaire only because I know I can get a picture. And
yeah, Frigidaire is kind of similar.
let me just get it. I'm searching an image for the heat exchanger now just so I can show you something here. So if you look at the heat exchanger, my internet is slow as hell, guys, and I pay for fast internet. Is this crazy? Oh, now it's loading, I think. Okay, so if you look at the heat exchanger, one of the things is the capillary tube is this smaller line, and it's soldered and it runs alongside of this suction line. Okay? And that's why it's called a heat exchanger, because the capillary tube is high pressure, high temp, and the suction line is low pressure, low temp, and they exchange heat between the two of them. So it helps the liquid freon in the capillary tube become vapor when it hits the evaporator, and it helps the vapor coming out of the evaporator turn back to liquid as it's coming back through the compressor. And they just call it a heat exchanger. It makes it more efficient, that's all it does. But what you're going to do, we do not want to remove any length of capillary tube, but the suction line we can. So what I usually do is I take a torch with very low heat and just heat up the pipe and pull the capillary tube away from the suction line. They use more like plumbing solder to solder the two of them together. So I just heat it up and I pull the capillary tube away. I cut off the excess suction line and I take the capillary tube and I wrap it around a flux bottle or wrap it around my a can or a flashlight or something and use zip ties to keep that excess capillary tube back there. But other than that, changing the heat exchanger, all the procedures that I do in that one video of Frigidaire, it's all the same thing in every refrigerator.
Thank you.
All right, I'll see if I can get a heat exchanger. Right now, we're building a refrigeration system in my class with my students. We've taken one of the mock things that students built, but we're improving it. And we're going to mess with the heat exchanger. And I'll show how to separate. You know what? I did it in my video. If you watch that video on the evaporator, I actually heated up the capillary tube and pulled it off with a torch in that video, I think. So I don't need to make one. Any other questions?
Rick, do you use a jeweler's torch or use a regular torch when you?
You know, I like to use turbo more in oxyacetylene, but I just bought a real nice wishbone tip. It's real small too, like 40, 50 bucks, but I like it. You know, you can get into small, tight spaces and it heats up pretty fast. I'm so good at the turbo. I can use turbo for almost anything. I know a lot of people don't like it because it's loud and it's got a big flame and heat everywhere. And with the oxyacetylene, you can more pinpoint the flame. You just got to be careful not to burn it up. But what frustrates me is, okay, bring the torches out. Let me check my regulators are set. My tank's got gas. Now let me turn these two little dials for 5 minutes and try to get the flame nice and blue the way I like it and not have black soot flying around the place. So, and then I turn it off and I go to do another braise and I have to readjust it all over again. That frustrates me. So again, I do like the little wishbone tip, which is similar to what you call the jeweler's tip. And I could use either one. It all depends on the job that you're using. You just got to practice it.
All right, thank you.
No problem. All right, everybody. Well, listen, you guys have a good weekend and keep an eye out for my invitation for the next class, okay? And I'll complete this